So we have learned.
Now, have the second one.
So we have learned how to build an images in lenses. Today we will learn how to do calculations with the lenses. So let's first start from constructing some image, and then we'll do calculation. So we have principal optical axis. We have convex lens. This is a focal point, and this is a focal point. And we have an object position here. So let's make this image. So we're using two rays, one going parallel to the principal optical axis. After their refraction, will go through the focal point, and ray going through the center of the lens is not refracting, so that will be the image. So this is the object, this is the image. Describe this image.
It's a real inverted magnified.
Yes. We need address. If it's real or virtual, it's real. If it's upright or inverted, so upside down, it's inverted, and it's bigger, smaller, it's bigger, so it's magnified. Now, let's say that, let's denote the distance from the object to the lens as u. U is the distance from where object is to the lens. Distance from the image to the lens we denote as v, and the focal distance we denote with f. And there is a so-called lens formula, lens equations, which connect these three quantities. Say that 1 over u, 1 over distance from the object to the lens, plus 1 over the distance from the lens to image equals 1 over f. Let's apply it. Let's say the focal distance is 20 centimeters. Let's say focal distance of the lens is 20 centimeters. And let's say object is positioned 30 centimeters away from the lens. Let's find where will be the image position.
Focal length is
Focal length, so we have 1 on 30, 1 on the distance from the object to the lens, plus 1 on unknown distance from the lens to the image, equal 1 on 20. Because focal distance is 20.
Wait, what actually is the definition of the focal length?
Focal length of the lens from the lens to the focal point. Focal point.
Just that on the
Just
straight,
this
not-
distance.
Okay.
From the lens to the focal point.
Yep.
Focal point is the point where when rays going parallel to the principal axis, after the lens they converge to it.
Yep.
Called focal point. So rearranging this formula, 1 on V will be equal 1 on 20 minus 1 on 30, bringing to common denominator, which is 20 and 30 will common denominator 60. So we'll have 3 minus 2 equals 1 on 60. So that means if 1 on V equals 60, what V equal? V equals 60 centimeters. So the distance
Oh, that makes sense.
from the lens to the image will be 60 centimeters. Makes sense how we have found image to the distance to the image. We substitute numbers into the lens formula, rearrange it, and find the distance. Now, we also can find if we know the height of the object. Let's say object has height of 5 centimeters. And using the similar triangles, we can show that the height of the image, this is a small h, the lowercase h is size of the object. Capital H is the size of the image. We'll have the ratio of the size of the image of the size of the object equal V on U. This formula connects the ratio of the height of the image divided by the height of the object equal distance to the image divided by image. It's just similar from the similar triangles. Substituting numbers, we get h over 5 equals 60 over 20. So h will be equal 15 centimeters. So height of the object will be, height of the image will be 15 centimeters. We rearrange it, we substitute into this formula. We know size of the object, 5 centimeters. We know distance to the image, 60 centimeters. Distance from the object is 20 centimeters.
Says that.
So we find the size of the image is 15 centimeters. Make sense? Also, this ratio of size of the image divided by size of the object, we call it magnification. So how many times object is magnified?
Come again?
How many times object is magnified?
Zoomed in. Oh, okay.
3 times.
What the ratio of
3.
h to h3? So object will be 3 times magnified. Also, 15 divided by 5 is 3. Now,
If it's like less than 1, does that mean it's diminished?
yes, yes. Now we'll do another example. Actually, we'll do 2 examples. More before that, is anybody in the class using glasses? Does nobody wear glasses now?
You're wearing glasses.
No. I'm asking from Zahar, are you using glasses?
Sometimes.
Sometimes. Do you know what are the optical strength of your glasses?
No.
No.
2020.
Okay. No. So, usually, if the glasses for short-sightedness, you say it's, let's say, -2 or -5 or -1. If it's for long-sightedness, you say plus. That is optical strength of the lens. It's denoted by the capital letter D, and it's equal 1 on focal distance. So,
What is these?
this is the optic strength of the lens.
D equals 1 over F.
1 over focal distance. So the stronger the glasses, the stronger the lens, the shorter will be focal distance. So the bigger will be dioptries, D. So if let's say, I have, let's say I have different on my left and right eye. On the left eye, I have -4. So if it has -4, so equal 1 on F, so what is the focal distance of my left lens?
-1 on 4.
Which is equal
-25.
centimeters. So it's equal -0.25 meters, so 25 centimeters. What does it mean?
That means it's in focus. If you look at
What does it mean minus means in front?
It's diminishing. It makes the other zoomed out.
Is diminishing, so it is convex or concave? It's concave.
Wait, that means
So
it's like
for
this.
concave lens, we take focal
Wow.
distance with a minus.
I don't
For
get
con-
it.
Always going to be mine. Because it's
For concave, yes.
That's your
For concave lens, we take focal distance with a minus. That's why we say that strength of the lens like -4.
Just for clarity, the F, is it just from the center to the focal point? Or
Yes.
is it the entire thing?
So from the center of the lens to the focal point.
Oh, because when it's concave, it brings all of these.
Yes. So this
It
is-
makes things smaller. It makes it says raised apart.
This image,
Now let's another example. Let's do another example. Let's do one more example with application. So we have again convex lens and we have object position here. This is the focal point. And we have object position here. What kind of image we will get if object position closer than the focal?
Unclear image.
Huh?
It's unclear. They don't mean.
upright is your image.
Doesn't it mean that they never
Will it
meet?
be virtual or
Oh, it's
real?
virtual.
virtual.
It will be virtual. Let's
Yeah.
build it. So ray going parallel to the principal optical axis going through the focal point.
Yeah, they don't.
Ray going through the center does not refract, so they don't meet, they divergent. So we need to find the image. We
These are optical stroke.
we continue the length, and that is image. Now describe this image. Real or virtual? Virtual. Upright or inverted? Upright. Is it diminished or magnified? Magnified is clearly greater than this one.
So look at this picture.
Now let's have, we have same focal distance, but we will have position at 10 centimeters.
Oh,
Now the distance from the object to the lens is 10 centimeters. Let's find position of the image. We have 1 on 10 plus 1 on V equal 1 on 20. Rearranging 1 on V equal 1 on 20 minus 1 on 10, which will be equal
Yeah.
1 on 20.
because it's negative 1/20 away from
Ah,
the lens. 'Cause it's
so
behind the
we'll
lens.
get-
It's the virtual image.
So that means when you get V, and so that's 1 on V, so V equals negative 20 centimeters. What does it mean, this negative distance?
It's before the.
That it's a virtual image. When you get distance with a minus, that will tell you that image is virtual.
But how do you see it? How can you see virtual? You have to get another lens. to get-
Because in our eye, there is a lens. There is a convex lens in our eye. By the way, how we focusing on the object, our eye focusing on the object close and then somewhere far away.
Our lens moves up, moves here and here. In our eyes.
It's not really moves your eye, that it doesn't comes out of your eye, but how we focus. The lens, remember, the focal length depends how thick lens is. So our muscle in the eye either compress lens, make it thicker, or stretch it to make it thinner. That's how our eye focusing on the object. The lens in our eye is not rigid. It can be stretched or compressed. So muscle in the eye regulate the thickness of the lens in the eye to focus it at the back, to focus light on the retina at the back, like screen in the eye.
No.
There, and
I don't think so.
when you have like bad vision, that means your muscle operating the lens does not operate properly.
That's
It's
why your
it's either too like too tense or too weak. So if the muscle in the eye is too tense, that you will be short-sighted. You will not see well far, you will see well close. If your muscle becomes weak, you start seeing bad close. That's why old people usually have a problem with the reading without the glasses. Because the muscle in the eye becomes weak with the age, and it does not, cannot compress it enough.
Short-sighted.
And
That's why people can't see short-sighted.
now short-sighted is when muscle is too tight and you cannot relax it enough.
Is it short-sighted when you can only see short, or when you can
You
only
can
see?
see close, well,
Oh yeah, well,
but
then
you don't see well far.
I meant the other way around.
With the age,
Then long
with the
sighted.
age, so with the age,
Look at that long-sighted.
pretty much majority of you will need glasses for reading because you will, so like your grandparents.
You
For
can't
example,
compress, you can't make the lens thick enough.
because yes, their muscle in the eye becomes weak with the age, like with all other muscles. It becomes weak with the age. Now, so does that example make sense?
Yes.
Now, what? And the last example, before we will start practice question, let's consider now concave lens. Now, let's make image in the concave lens. So this is the principal optical axis. We have concave lens. This is the focal point. And we have an object. So ray that going parallel to the principal optical axis, after the refraction will go like it going through this
Yes.
focal point.
That's what you taught me how.
And this will go without change.
So the image is there.
So this will be the image. This will be the image. And that will be virtual,
Diminished.
upright, and diminished. Now let's find distance. The only thing, because this is a concave lens, we must take focal point -20. For concave lens, which is divergent lens, we take focal distance with a minus. So let's say this distance is 30. Applying formula, we have 1 over 30 plus 1 over equals negative 1 on 20. So we have V, 1 on V equal negative 1 on 20 minus 1 on 30. So will be 1 on V will be equal. What will be negative?
Negative 5 on 60.
Negative 5 on 60. So V equals negative 12 centimeters. Minus means that the image is virtual, that we already achieved, that it will be 12 centimeters from the lens. Negative means it's virtual image. Now let's find the size. We apply the same formula. H, size of the image of the side of the object, equal,
Mr. Big.
yes,
So if it means that's negative 12 centimeters, that's it's negative, the image is negative is 12 centimeters to the left from the left.
On the same side as the object. So we have h divided by 5 equal 12 over 20, sorry, over 30. So we will have height will be equal 2 centimeters. So as you can see, we got through the construction, we get all. We got image diminished, and our calculation showed that it is object 5 centimeters, image 2 centimeters.
Is
Yes.
that the height where the arrow is?
Yes, this is the height of this image.
H is virtual, the little H is.
Capital H is the size of the image. Lowercase h is the size of the object. That's how we apply the length formula. Like, subscribe, and donate to help fight Russia, to help fight terrorist countries and organizations, Russia, Hamas, etc.